I'm going to take you on a very much a whirlwind tour of Antarctica, the ozone hole and climate change, and perhaps what needs to come next in terms of saving the planet. So the bit of the Antarctic that I work in is what's called the British Antarctic Territory, a pie-shaped slice of Antarctica running from 60 south to the pole. And the two main stations are Halley and Rothera, but most recently I visited King Edward Point up on South Georgia. But I want to tell you a bit about ozone and what it is and how it's made. So it's a form of oxygen that we breathe, but instead of having two atoms, it has three. And it's created naturally in the atmosphere by a series of chemical processes. And the gas was first discovered by a Swiss-German chemist who was actually experimenting on electrolyzing water. He was passing electric current through water and seeing what happened. And by accident, in the process, he found that some of the gases coming off had a funny smell, and that was ozone. Now, to find out exactly where the ozone is, we can launch these weather balloons that can carry, on occasion, a larger package that chemically measures ozone as it goes up. And that shows us where our so-called ozone layer is. It's a broad layer from about 10 to maybe 30 kilometres, where the majority of the ozone in the atmosphere occurs. What it does is the really shortest wavelengths of ultraviolet light are blocked completely by our ozone layer. Astronauts have to worry about them, that's why they often have this gold visor that comes down over the spacesuit, but at the surface we don't. Somewhat longer wavelengths do get through, but they're partially absorbed by the ozone layer, and the longest wavelengths come through more or less unchanged. So if we can measure the ratio of intensities of the two wavelengths, we can work out how much ozone was present. If the two are more or less the same intensity, there was very little ozone in the ozone layer. If, on the other hand, this is much more intense than this one, there was a lot of ozone in the ozone layer. When I joined the survey, one of the tasks I was given was to supervise two ladies who were typing in the numbers into the computer. Also about this time, we had an open day at the British Antarctic Survey where we were showing the latest science to the public. And I thought, well, there's all this fuss that Concorde can destroy the ozone layer through its exhaust gases, and spray cans can destroy the ozone layer through the CFCs, the chlorofluorocarbons that they contain. And me, being a recent physics graduate from Cambridge University, thought, what a load of rubbish. How on earth can a spray can destroy the ozone layer? I know. I'll show people this year's data, and I'll show them 20 years previously which had been computed, and they'll be the same, and we can stop worrying. Didn't quite work out like that. And eventually I was able to go back through all the data and draw up a graph, and again, this is 25 years ago, so it's a hand-drawn graph. And the key thing was that we'd got continuous data going back to 1956, and that I could show that it was systematic. We've got no gaps in our data, we've got a long period, and it's going down continuously. So something must be causing it. And it must be something in the atmosphere because we've ruled out everything else. And it was basically that graph that led Joe Farman, Brian Gardner, and myself to publish in Nature this paper that linked the increase in chlorofluorocarbons with the decrease in ozone. So, are things improving? Well, at a quick glance at this graph, yep, the curve's turned round and it's going up. But this illustrates a danger of using computer graphics packages. And you have to ask the question, is there any physical reason why ozone in the atmosphere should follow a third-order polynomial? And there is no physical reason why it should do that at all. And I would say what we really had was maybe a decade where ozone values dropped very rapidly, maybe a bit more than that. But then since then, we've been on a plateau where there really hasn't been much change. And why are we on that plateau? Basically because our big peak in ozone has gone down to virtually nothing for the 15 to 20 kilometres range. Once you get to zero, you can't go any lower. So that's why we have that plateau. We also have to answer the question, why is nothing going on up here and why is nothing going on down there? In the winter, the air cools, air descends, it begins to rotate, and it acts as a barrier called the polar vortex, which isolates Antarctica from the rest of the world. But as the sun begins to come back, we see the ozone hole beginning to form. And by the time we get to the end of September, it's at its largest and deepest. And you can see that sometimes it spills northwards over the tip of South America and the South Georgia. As it gets warmer in the late spring, the atmosphere warms up, the ozone hole begins to fill in, and we, broadly speaking, have a uniform distribution of ozone across the continent. And then the next year, that cycle will start again, and we'll have another ozone hole. So the ozone hole isn't a permanent feature, it's a thing that is there only during the Antarctic spring. The key thing about this idea is it predicts that the concentration of chlorine monoxide will become very high. So if you've got a scientific theory, you've got to use it to make a prediction. And then you have to test that prediction. And the Americans duly tested it by flying a special satellite that mapped where the chlorine monoxide was. And that showed very clearly that where there were high levels of chlorine monoxide, there were low levels of ozone. And that really proved the theory. And as a result, the Montreal Protocol and various extensions was drawn up that prohibit the release of CFCs into the atmosphere, and it's working. The amount of CFC is going down, but because they're very stable substances, they'll be with us until maybe 2070 or 2080. We have that long to wait before there's no ozone hole, assuming that everybody obeys the treaty. And amazingly, it's the only treaty that all the UN member states have actually signed. So it's something that everybody has been able to agree to.